Whoops. Okay, so let's have a look at G and H, and then we'll move into some other types of factoring. So G and H here. First thing we need to do is multiply the first and last terms. So 5 and 8, I'm going to multiply together. Nobody put any answers in the chat, or I don't think anybody did. Let me just check here. No. Okay, so maybe, I'm not sure if people don't know how to do this, or maybe it's just too early in the morning. It is 8:20, and I had students writing me a WhatsApp at like 2 a.m. Why are you guys writing me at 2 a.m.? Anyways, it's pretty early. I don't have any answers in here. But the first thing I would do is multiply 5 and 8. And actually, I should say 5 and negative 8. So 5 times negative 8 would give me 40. Well, or negative 40. Okay, I'm just going to make like some mental notes on the side, or not mental notes, but make some notes on the side. So I need two numbers that are going to add together to give me a 6, but multiply together to give me a negative 40. So probably 4 and 10 would work for that. Well, and again, like I'm not mentioning the negatives, but negative 4 and positive 10 would certainly work. So what I do, so let me write that down, negative 4 and 10. Oops. So what I'm going to do is split this middle term here into that 4 and 10. And really, it doesn't matter which order I write them in. I know I mentioned this yesterday, but I don't know how much I like emphasized it. It really doesn't matter if I go negative 4 or 10 first. I'm just going to go with the bigger number first. So 5x squared plus 10x minus 4x minus 8. It literally would make no difference if you put the minus 4 first and then the 10x. Really doesn't matter. Okay. So now I'm going to factor by grouping. So in the first two terms, I can take away a 5x, leaving me with x plus 2. In the second two terms, I can take away a negative 4, leaving me with x plus, watch out for your negatives, 2. And this works because what's left in, what's left in the brackets is the same. It has to be the same. This isn't a coincidence. And by the way, if you missed class yesterday, you might be a little confused at this, but a little bit of practice, this is pretty straightforward. So x plus 2 and 5x minus 4. And that's it. We have factored this trinomial. Okay, let's very quickly do H, and then I'll move on. Okay, so H, 4 times a negative 6, that's a negative 24. Now I need two numbers that are going to multiply to give me a negative 24, but add to give me a 5. So there's 12 and 2, there's 8 and 3. 8 and 3 probably will work. And yeah, that'll work. We'll go negative, or no, 8 and 3 don't work. Hold on. Yes, they do. Sorry. Too early for me too. So we could have 8 and negative 3. 8 times negative 3 is negative 24. 8 plus negative 3 is, of course, a 5. Okay, so split the middle term here. 4x squared plus 8x minus 3x minus 6. Again, doesn't matter which order I put them in. I'm going to factor out from the first one, a 4x, leaving me with x plus 2. And from the second one, I'm going to factor out a negative 3, also leaving me with x plus 2. And then there we go. There's my answer. So x plus 2 and 4x minus 3. There we go. Factoring. I don't know why. But when I was a kid, or not a kid, I guess, but you know, a young adult, I guess, a teenager, I love this stuff. All right, what's going on in the chat? Yeah, there's someone in the chat mentions another method, Delta's Law. I've never heard of that. So that's something maybe you guys can check it out. But this is, yeah, I've never heard of Delta's Law. Sorry. All right. So, excuse me. There is another example here, another practice example anyways, and just more practice problems. Again, you know, kind of up to you guys to maybe practice some of these. I highly recommend practicing the questions on page, say, 19 and 20. So let's move on to another type of factoring. Yeah, I think there's two more. There's difference of squares, and then there is sum and difference of cubes.
Sir,
Yes?
tomorrow will be a class or?
Yeah, tomorrow I'll have class, but it'll just be a review. So we do like
the exam will start at 11:30. So how we will review?
well, because class starts at 9:30 tomorrow, doesn't it?
Yes,
So
till
then,
11:30.
yeah. So then, yeah, we'll have a review.
So we have a class and we have a test in the same
Yep.
time.
Nope, the test is at 11:30.
So we will be in the campus at 9 to review the to watch the class and the test.
Yep.
Okay.
Yep. So yeah, guys, the test tomorrow is at 11:30, and the reason it's at that time is it's for every section of Math 1700. There's, I think, 5 sections of you guys, so we're having every section do the test at the same time. So it's not just you guys; it's everybody will be there tomorrow at socially distancing, of course, at 11:30. You can see that on the not front page, but news page of the D2L. Nasser, you have a question?
Yeah, hello, good morning, Mr. Mark.
Mm-hmm.
I was going to ask about the review today. There's going to be a review at the evening?
Yeah, I'll make a posting after this class. Maybe not so much a review, but if people want to come and ask me questions tonight, I can be available on Zoom, you know, maybe, I don't know the time, probably around 7. I can have basic, well, you know, people can stop by and ask me questions if you have any questions.
Okay, sure. Thank you.
Cool, no problem. All
Mr.
right.
Mark,
Yes?
tomorrow we will have a class?
Yes. I just literally just talked about that.
On campus?
No, there's never going to be a class on campus. Classes are always 110% online.
Okay, thank you.
No problem.
But you have to be in the campus before 11:30.
You guys do. I don't. You have to be on campus at 11:30. Yes.
Okay, thank you.
Yeah, no problem. The test tomorrow is on campus, in person, not online. All right. So difference of squares. Let's have a little look at this type of factoring. Difference of squares. Example of squared. Oh, well, yeah. First of all, what is a squared number? A squared number is, or I guess what I used to call this is a perfect square, is a number, how do you, like, I don't know, when you multiply a number by itself and it creates a new number, that's what we would call a squared number. It's kind of really hard to explain, but it's simple when you just look at the examples here. 9 is a square number. And the reason it's a square number is because 3 times 3 is 9. 16 is a square number because 4 times 4 is 16. So a squared number is, again, what I used to call it a perfect square, is when we take two numbers, or like we take a number and we multiply it by itself. So 5 times 5, 6 times 6, 7 times 7, that would create what's called a square number. Now, you can also have squared expressions. So like x times x or y times y, these would be squared expressions. So you can actually factor what's called a difference of squares. Sorry guys, hold on one second. Okay. Now the key word here is difference of squares. Difference in math meaning subtract. An algebraic term is a perfect square when the coefficient is a perfect square and the exponent is an even number. And I'll show you some examples of this, but all of these on this page are examples of differences of squares or perfect squares. Now, one interesting one here is 81x squared y to the 4 minus 1. 1 is a perfect square, right?
1 squared by 1 by 2.
Exactly. So 1 times 1 is 1. So it doesn't look like a perfect square. You know, it doesn't look like 9 or 16, but it is. 1 times 1 is 1. 2 times 2 is 4, 3 times 3 is 9, but 1 is a perfect square. Interesting. So the way that this works, there's a lot of information here, but it's actually pretty straightforward, is you take the square root of each sign. I'm going to show you this, guys, don't worry. But you take the square root of each, not sign, but each term, and one of them is positive, and one of them is negative. And again, I'm going to show you. It's probably easier if I just actually show you this. So, well, yeah, here it is here. The factors of a difference of squares, two perfect squares will be so in this case, if it was like a squared minus b squared, remember, it has to be minus. That's what difference means. It would be a minus b and a plus b. One factor is the square root of the first term plus the square root of the second term. And the other factor is the square root of the first term minus the square root of the second term. Sounds complicated, but it's actually not that bad. And you can see the dumb little light bulb man here mentions on your calculator, like for some numbers, you might not know if it's a perfect square. You can use the square root button, which looks like that symbol there, right there, on your calculator. So like a big number like 121, for example, if you put this in, I'm up here in the top right of the screen. If you put that in on your calculator, it will tell you that it's 11. So you might need to use your calculator to check some bigger numbers. So here's 4 examples, 5 examples even. Well, I'll definitely show you example number 2, but I think I'd rather just maybe do one of these down below just to kind of show you how it works. But look at example number 2 for a second. That can be a challenging one because, again, like I just mentioned, not everybody recognizes 1 as a square. Or again, like when I was a kid, we call them perfect squares. I don't know. Anyways. So the idea here is, let's look at example number 1 first. We have x squared minus a 36. So the factor of this difference of squares would be x and 6. And it's x minus 6 times x plus 6. It's always one term is negative, one term is positive. If you look at example number 2, a little bit more complicated here. What is the square root of 100x squared? Well, it's 10x. 10x times 10x is 100x squared. Now, this 1 the square root of that is just 1. So this would be 10x minus 1 and 10x plus 1. You can see all these examples here, but let me do one for you. Oh, one little hint here too, by the way. And you can see this in example number 5. No matter what you do when you're factoring, always look to see if you can first remove any common factors. So you can really see this with example number 5. This looks impossible to factor, like as a difference of squares. But if I can remove a common factor, in this case 2y, it actually becomes a lot easier. So in this case, I remove 2y. Now it becomes a difference of squares. I have 16x squared and 9y squared. So that would be 4x and 3y. All right, let me show you some. So, what one do I want to do? Well, I'll definitely do D. I mean, A. Okay, let's just get warmed up here for a second with A. So A, it's a difference between two perfect squares, x squared and 16. So what I do first is I write down what we call the square root of x squared, or just 1x is what I get. And then 16 is 4 squared. So this would be x minus 4 and x plus 4. The order that you write that in doesn't matter. You could write x plus 4 times x minus 4. It really doesn't matter. Just make sure 1 is positive and 1 is negative. Okay, what about something a little harder like question D? Well, I already told you about 121, one of my favorite numbers. The square root of 121 is 11. That's, if you're wondering where I'm getting some of these numbers, like where did the 4 come from? The square root of 16 is 4. And you can do that on your calculator. If it's not something you can do in your head, there is a square root button on most calculator. Well, every calculator really. If you're using your phone, it might not be as easy to find, but it is there. So D would be 2a minus 11 times 2a plus 11. All right, the square root of 4 is 2. The square root of 121 is 11. So this would be 2a minus 11 and 2a plus 11. So why don't you guys try a couple of these? I'll make you, or I won't make you do anything, but something like C and E you could certainly do, and maybe see if you can try F as well. So I'll just give you a couple minutes to try these, and then we have one last type of factoring, difference or sum of cubes. And then you won't have to worry about factoring for a while. So try C and E, and if you can, try F, and I'll be back in a few minutes. Okay. Some good looking answers in the chat there. From Sana and Samira and Dustin and everybody else. Sorry, there was a question there I missed from earlier from Sana or Sana. I don't know if I'm saying your name right. The test should only take you an hour, so 11:30 to 12:30, but you can have the full 2 hours. But don't panic about seeing it. Like I think on D2L, I mentioned that the test was 11:30 until 1:30. That's just the time that we have the room booked. We had to book the room. The test shouldn't take you more than an hour. It's literally a regular test, right? I don't know if that means anything to you as students, but what for us in the college, we only really make 1 hour, or at least in math, only 1 hour tests. So to a long answer to your question, it's 11:30 to 1:30, but it is only designed to be an hour. All right, so let's have a look at these answers here. Now, most people got C and E, but I didn't really see any answers to F, or there might be some in there now, but let's have a look. So 5p minus 8, 5p plus 8. Oops, that is an ugly 5, but you get the idea. That is a 5p, not an SP. One thing I'll mention, if you guys had 5p plus 8 and then 5p minus 8, that's the same answer. It doesn't matter what order you put them in. Remember the properties, right? In math, A times B is the same as B times A. So it doesn't matter which term, or not term, I guess, but which binomial you write first. Okay, E would be 16x, so 4x. 16x squared would be 4x minus 7y. 4x plus 7y. Okay, and then F would be, we have 4 again. F is a little harder, and really, it's not that it's actually harder, it's just there's an extra term in there, but that doesn't really make it harder to calculate or work out. Here I would get 4xy squared minus 7z, or z if you're Canadian. We say Z in Canada. I don't. I've always hated it since I was a kid. It doesn't rhyme with the alphabet song. I don't know if you guys know the alphabet song, but Z doesn't rhyme. So I've never liked it. I like to say Z. Oops, speaking of Z, there we go. I put a Y there by accident at the end. So now for F, if you're wondering, or if you had troubles with F, basically I'm taking the square root. I don't want to say dividing by 2 because that's not what the square root is, but when you're thinking of exponents, that's kind of what's happening. So I had x squared y to the power of 4. When I take the square root of that, I end up just getting x1, so 2 divided by 1, and then y squared. Y to the power of 4 would just be y squared. So again, I hate saying dividing by 2 because there's a little bit more happening there behind the scenes, which we're not going to get into. But yeah, anyways, if you have trouble with something like F, don't worry. Typically, you would see difference of squares like A, B, C, or D. Something like that is more common. One thing I'll mention too before I move on to the last part of factoring finally, some of the problems in the book are purposefully difficult, and that's just to make sure that you're ready. When you're studying, the book is the best thing to study, but remember, like, we're not trying to put the hardest questions there. So, something like A, B, C, or D would be good for a test. Something like F or even J, J's a really interesting one, actually. Maybe a little bit too challenging, but good for practice. I'll leave J for you guys. J is a good one. Okay. Oh, there is another question here before I get into the last part. Do I want to bother with this? Let's just do maybe one or something of these, or at least we can do, I don't know, A and B, and then I'll move into the last part of factoring. So the only difference with number 2 here is that there's an extra step. Like when I look at A or I look at B, it's not apparent to me, or it doesn't, like, it's not clear to me that this is a difference of squares. It doesn't look like it. But what, like, again, the first thing you do with any factoring equation is see if you can remove any common factors. So you would do that before anything. So when I see question A, well, I know I can factor out a 3. So when I factor out that 3, when I remove the 3, I get x squared minus 4. And now I notice that there's another step I can do. And this is kind of like the challenge of factoring. I remember doing this when I was, I don't want to say your age, but I don't know how old I was. I was in my teens. And sometimes I would miss a step. I just wouldn't go far enough. And this was actually one of the types, especially something like B, where I might not recognize that my math teacher was, I don't want to say playing a trick on me, but had like the question secretly harder than what it appeared to be. So, when I was younger, I might stop here. But if you look carefully, this is a difference of squares. So I can keep the 3 outside, and I can go x minus 2 and x plus 2. And there we go. Now I've actually completely factored it. So yeah, it can be like solving a puzzle sometimes. The answer is in there. You just have to find it. Like for B is one I would definitely miss when I was younger. So for B, I can certainly factor out an x. And I'm left with 25x squared minus 1. And again, I would be tempted to stop there, but if you look carefully, this is a difference of squares. So I would say, okay, keep my x, and then I could have 5x minus 1 and 5x plus 1. So, just be careful. And this goes for your test or your final exam or, future courses in your engineering or medical science courses. Be careful. Always, double check your answers if you have time. And you certainly will have time tomorrow because you won't need 2 hours. All right. Okay. Oops, sorry there. I wrote Abdullah. I meant to write Suher. Oh, I have a question, actually. Sorry, I didn't mean to write you, Abdullah. The student in the chat, Suher, what is that your name on the not on the attendance, but like at the college? Like, can you maybe, do you go by another name? Because I couldn't find you in my attendance list. This is for the student Suher, Suher. Do you have like another name or a student number you can give me or something? Because when I was doing my attendance over Eid, I couldn't find you. Okay, perfect. Thank you for that. To the people in the chat, or sorry, in the rest of the people in the class wondering what I'm talking about, don't worry. The student just gave me a student number, so that's perfect. Let me write that down first, actually. And then I will do the last part here. 6. Okay, I don't know why I almost said that out loud to myself. Okay. Cool. So one more type of factoring. Now, this is a type of factoring. The last one, type 6. I don't know why, we're teaching you every single type. This one can be a little bit more confusing, but there's formulas. Sorry, in my brain. I was trying to talk and read something else at the same time. These formulas are given. Okay, so I'll show you what these formulas mean in a minute, but you do not have to memorize any formulas for math. Okay, you don't have to memorize any formulas. So anytime you need a formula, like later at the end of the course, we'll be doing trigonometry. So if you guys can remember that sine, cosine, tangent, you will be given formulas for that. All right, just give me 1 second, guys. I need to check something and then I'll be right back. So maybe you can have a look at these examples here and I'll be right back. I just need to check one thing. Okay, sorry about that. I just had to check one quick thing. One of my teachers was writing me an email there. So anyways, I'm back. Okay. So the last finale, the last type of factoring, recognizing sums and differences of cubes. So, okay, first of all, maybe this is something you're not familiar with. What is a cube, right? What is a cube number? A cube is like a square, a perfect number, except instead of multiplied by 2, or not multiplied by 2, but instead of being squared to the power of 2, it's to the power of 3. So 8 would be a cubed number because 2 times 2 times 2, and you can try that if you don't believe me on your calculators or on your phones, is a perfect cube. 3 times 3 times 3 would be 27. These, by the way, are a lot harder to recognize. I wouldn't worry too much about these. You might you'd be getting pretty simple ones, meaning like these numbers here. Nothing any bigger or crazier than those. How would you do this on your calculator? Well, every calculator can do this. You just need to find the right button. If I am using a Casio calculator, I can find this button. It's called the cube root button, as the second function of my square root button. I tried to show the other class my calculator the other day. Oh, you know what I could do actually, guys? Hold on, I got a plan here. Oh, that's perfect. It's in my history and everything. Okay, just hold on. I'm just bringing this up on Google. I know you guys can't see my screen, but I'll show you in a minute. Oh, I did the same thing I did the other day. Hold on here. Open image in new tab. I will share my screen. So if you, and I highly recommend, I mean, you need a calculator. You're going to need one for this course, for engineering, for whatever you're in. I highly recommend getting this type of calculator. So if you can see my screen here, it's a Casio brand. It's sold at the bookstore. You do not have to get it at the bookstore. I think they sell them at Carrefour, maybe Lulu. I've definitely seen them in the past at Carrefour. Anyways, it has a square root button, and this isn't the best picture, but the square root is right here. And if you look above it, there's yellow writing. This is not the best picture, so you kind of have to squint or whatever. But if you look above this button, there's a cube root button, which will take the cube root of numbers. What that means is it would take something like 8 and it would look like this, and it would give you the answer of 2. The cube root of 8 is 2. Right? So what I'm saying is you don't have to memorize these your calculator can do pretty much anything you can throw at it. The only problem with the calculators is it doesn't do X and Y very well. Okay, so cubed variables, these would be variables that are multiples of 3. So x to the power of 3, x to the power of 6. Really all you need to do, and we're going to practice this in just a minute, is recognizing them, meaning like looking at in this case, a binomial, and recognizing that it's a sum of cubes and difference of cubes. And once you recognize it, you are going to apply a formula. The formulas are here. Okay, so let's do some. This is easier than it looks because, again, the formula is given to you. This, again, you do not memorize this, okay? You definitely don't have to memorize this. So this is the sum of cube formula. This is the difference. Just remember what those words mean in math. Sum means add, difference means subtract. So a cubed plus b cubed, or a cubed minus b cubed, these are your answers here. There's really not much to say. You just have to follow the formulas. Now, let me show you this example. I'll show you the difference of them, and then we'll do some practice. Okay, so first example, starting off with an easy one. How would you factor x cubed plus 8? Well, the first thing you need to recognize is that this is a sum of cubes. Now, how do I know that? Well, I know that 8 is a cube. It's a perfect cube. 2 times 2 times 2 is 8. So what I would do is ask myself this question. What number or variable is cubed to give each of these terms? The reason you ask yourself that question is so that then you can use this formula here. So x cubed, that's very easy. 8, I'm going to rewrite that as 2 to the power of 3. So a, in my formula, a is x and b is 2. Then I literally just plug, I say this word a lot, plug, I mean, put these numbers into the formula and halas, you are done. The only thing to remember, or well, there's a few things to remember, of course, but just be careful, when you multiply a and b, or take the, b squared or a squared, try and simplify that as much as possible. Meaning, a times b, so we said a was x and b was 2. Don't write x2. What we would typically say in math is 2x. I don't think I'd take off a mark, but some other math people down the road might be mad at you. I would never be mad at you. So again, I'm going to show you some examples. Don't worry. This one's much harder. This is about as complicated as they would be. This is 27x cubed and 64y cubed. So the minute I see these cubes here, my brain does start to think about a difference or a sum of cubes. Now, you'll notice that the terms are subtracted. So this is going to be a difference of cubed. So now what I need to do is figure out what value is going to be A and what value is going to be B. So I need to figure out what is the cube root of 27, and that's 3. You can see that here. The cube root of 64 is 4. There's my B. And then I literally, so you can see here in the yellow box, I take that A and that B and I plug it into the formula that you guys will be given. So, yeah, let's practice. I wouldn't worry too much about this, especially some of the harder ones like these down here, like J, would be very good for practice. But, typically your difference of cubes would be something nice and straightforward like A, B, C, or D. So, what one do I want to do? Well, I'll do B. I was going to do C, but maybe I'll let you guys try C. So B is nice and easy. Okay, first things first, I see a subtract sign there. That means I'm going to be using my difference of cubes formula. So A cubed minus B cubed. The only thing I need to do is figure out what my A is, which is of course X. That's easy. But what's my B? So 27, is that a perfect cube? Well, there's only a few options really. There's 1 times 1 times 1. There's 2 times 2 times 2. There's 3 times 3 times 3. Now we're getting somewhere. And you can try that out on your calculator if you don't believe me, but 3 times 3 times 3 is 27. So there we go. Now all I do is I plug it into the second formula. So this factored would be, I'll just write it below here, a minus b, so x minus 3. Then it would be a squared, so x squared. Then it would be a times b, so that's 3x. Then it would be b squared, so that's 9, or 3 squared. Guys, I'm not going to write 3 squared. Like I know I just did, but what I mean is I'm going to write that as 9. So again, 3 squared, I'm just going to write that as 9. All right. If you didn't have the formula, this would be pretty confusing, but this is actually pretty straightforward given this formula here. So why don't you take a minute and try question number C. And then we've officially finished factoring. All right, so try question number C. Okay. So let's have a look at this. Number C. Okay, sorry about that. Didn't mean to sniff into the mic. Probably pretty loud. So number C. This is a sum of cubes. And I know that because they're added, excuse me, added together. So what you need to do, as for, just like we did with number or letter B, is, well, one, we need to know the formula. And then two, we need to find out what A and what B is. So A would be my first term. That would be 2A. And B would be my second term, which we've already done, 27. It's just 3. So now I plug it into the formula. This would be A plus B, so 2A plus 3. And then it would be A squared. So now, A squared. I'm not going to write A squared. I'm going to write 4A squared, right? Like 2A times 2A. Minus A times B, which is 6A. And then B squared, which is, of course, that 9 again. All right, so there you go. Not the easiest thing, also not the hardest thing, because luckily we're given formulas. Perfect. Yeah, okay. Sorry, I just checking the chat there from Bilal. Yeah, perfect. You said X, A, X, it's all the same. Cool. All right, so we're almost done. I have about 2 pages that I want to show you before we finish for today. There's lots of extra practice here, which I highly recommend you guys try. Like the best part about this page, 29, is that this is kind of like a mixture of everything. So we have trinomials, we have difference of squares, we have all sorts of different types of factoring you can practice down here. Highly recommend you guys check this out. And the answers, I've mentioned this before, and I guess we should know by now, or hopefully we know by now, the answers are all online. All right, so we only have about 15 minutes or so left before you guys, I'm sure maybe you have another class at 9:30 or something.
So we still have topic 13, 14.
Yeah. Oh yeah, they're very short. Like they're 2 pages each. So we're very, very close to being done. Shouldn't take us too long here. Topic 12 was huge.
Sir,
Yes?
can you please, when we finish the class download this lecture in the YouTube?
Yeah, sure, no problem.
Okay, thanks.
All right, so this won't take
And yesterday one.
Yes, sure, no problem. This won't take us too long, actually, to finish these. Again, topic 12 was crazy. Most topics are only very short, and this is one of them. This actually shouldn't take us too long. So this is kind of where the best part of algebra kind of kicks in. Simplifying rational expression, the whole idea of rational expressions. So we looked at this in Unit 1, and this is actually a very good continuation of what we just did. We did this in Unit 1, but now we're going to kind of apply factoring to this. So rational expressions are basically formulas, or not formulas, but like, it's hard to say because it's like an expression. So it's like numbers, they could have variables, could be A, could be B, could be X, could be Y. But in Unit 1, so well, not a month ago, I guess 3 weeks ago, in Unit 1, we didn't really have the skills to do much with this. We didn't know factoring, you guys might have known factoring, but we never practiced it until topic 12. So we can actually simplify these expressions sometimes by applying what we just learned, by factoring and canceling like terms or expressions. This is why I'm doing this today, because this is like a perfect follow-up of factoring. So factoring the numerator and denominator, we cancel any terms that appear on the top and appear on the bottom. Now, I am going to show you some examples here. There's a bunch, but I want you just to look at example number 1. Example number 1, if you looked at this a few weeks ago, you know, the beginning of May, this is it, right? There's nothing else we can do. Like, again, I'm pretending this was a few weeks ago. There's really not much we could do. But now that we know how to factor, and we've looked at all types of factoring, 6 types or whatever it was, sometimes once you factor, you will notice that you figure out or find like terms. You're going to hear me say that a lot between now and next week. Like this topic continues into like topic 16, 17, 18. We're going to be dealing with rational expressions for at least another week. When you hear me say like terms, these are numbers or expressions that are the exact same, and they're on the top and they're on the bottom. So this crazy looking fraction here, or expression, can be simplified to 3/5. So let's look at some harder ones, and then I'll do some examples here with you. Example number 2. So again, very tricky looking rational expression. But if I can factor these, and I'll try, I'll use all of my tips, all of my tricks, every type of factoring I'll try and think about. In this one, it's actually simple. We're just removing the GCF, which is 2x. You can see it being removed here. I can remove a 2x from the top and the bottom. And those 2x's cancel, because they are what we would call like terms. So I have simplified this equation. Now, I will give you a warning. Sometimes all the factoring will not be always so easy. Like, for example, you might see factoring like this trinomial here, 2x squared plus x minus 6, 2x squared minus x minus 3. You might not always have the easiest rational expressions. But rational expressions. But what you do is you factor the numerator and denominator and cancel any of the like terms. If you can't remember, you can see workings for this here and here. We did this yesterday. So let me show you a couple, right? It's not as hard as it sounds. There's a little note here about being very careful with negatives. Just watch out for any negatives, okay? Integers or negative numbers can be very, not confusing, but like if you miss them, you might make a common mistake. So be very, very careful when you see things like x or negative x or something like that. All right, so let's look at an example here. Question, we can do most of these pretty quick. Why don't I try a hard one? Not that any of these are that hard, but why don't I try one that's not, say, as easy as A or B? So question number C. I want to find, and what this question would say, if this was like a test or a final exam or an assignment, this would say simplify. So I want to see, is there any way I can make question number C simpler? Well, I start to think about all of my factoring tips and tricks, everything I've done with factoring. This looks like a difference of squares. The bottom is what we would call a trinomial. So let's see if I can make this simpler. Okay, well, the top is a difference of squares. This would be y minus 5. Whoops. And y plus 5. Okay, we just did that, so hopefully I don't have to review that part. What about the bottom? Well, this is a trinomial. So what I need to do is factor this by thinking of two numbers that are going to multiply to give me a negative 20 and add to give me a negative 1. This we did yesterday. So if anybody missed class yesterday, I'll put it up on YouTube for you guys to watch. So this, when I factor this guy, it will be y minus 5 and y minus 4. You might want to review yesterday's class if you don't know where that came from. But again, the method is I need to, y plus 4. I need to find two numbers that multiply to give me a minus 20 and add to give me a negative 1. And those two numbers are negative 5 and positive 4. So y minus 5, y plus 4, then cancel anything that appears on the top or the bottom, and that's it. Done. Halas. So why don't you guys try one or two of these? Like D, I think would be a good one to practice because it's so quick. You could try B if you want, but why don't you guys try one of these for practice? At least D. You could do B if you want as well. B is actually pretty quick. Oh, thank you for the answer there, Fatima. That's excellent. And then we're almost done. So yeah, why don't you guys try D, maybe B, and we'll check your answers in a minute. All right, let's check your answers. I got some stuff going on in the chat there. Ooh, okay, cool. So let's see what you guys got for D. Actually, like, for example, we could do question B really quick here. Try and factor anything you can out of that. So I could remove a 5 from the top, and I could remove a 9 from the bottom. Right? And that would just be 5 over 9. Pretty easy. I think I did that right. D is a little bit more work because D is a difference of squares on the top. So this would be x minus 4 and x, plus 4. And then on the bottom, I could factor out a 2. So then I would get x minus 4 here and they cancel. Boop, x plus 4 over 2. Let me just check the chat one more time, see if that's what everybody got. X plus 4 over 2. Perfect. All right. So almost done. I just got one quick thing to show you, and then you guys should be good. I had a question from, I think it was Nasser earlier. If anybody has questions, I have class this afternoon, but if anybody has questions about anything, so topics 1 to topic 14, you guys can come by and meet me on Zoom tonight. I'll make a little post later today. It'll probably be around 7:30, after I eat dinner. And if you guys have any questions or you want me to do some examples, feel free to let me know. So this is the last topic. I'm sorry that it's a bit late. I spent a bit more time on factoring this morning than I thought I would have needed. But this will only take us a minute to kind of finish up here. This is, again, a very short topic. The topics like 12 and 11 were quite large, 13 and 14 a little bit more straightforward. This is for multiplying and dividing rational expressions, which is basically what we were just doing. This is right here, we're dividing rational expressions. So one thing when you're looking at this is, first you multiply or divide them like you would any fraction. So just like you did in junior high math, high school math, whatever it is, if you multiply fractions, you multiply the tops, you multiply the bottoms. Really no problem there. This is a bit, not a bit new, I guess, but just a reminder when you, and maybe some of you haven't done this in a long time, when you divide fractions, however, we don't actually, on paper, divide them. What we would do is multiply by the reciprocal. So what is a reciprocal? A reciprocal is the flipped version of that fraction. And I hope you guys can kind of remember that from, I don't know when you would have learned that, but when you were first dealing with fractions, when you multiply fractions, you multiply the tops and the tops and the bottoms and the bottoms. When you divide fractions, you multiply by the reciprocal. And again, reciprocal here means to flip that fraction over. So we would follow the same rule with rational expressions. And I'm going to show you these examples, and then I'm pretty much done for today. Or I am done for today. Well, I have 2 more math classes, but you know what I mean. So when you're working with rational expressions, if you see the divide sign, which I really hate, I really don't like this using this symbol. You won't see him very much. But if you did have to divide 2 fractions, just remember the rule, you multiply by the reciprocal. Other than that, this is exactly what we just did. Once you multiply or divide a rational expression, don't forget to try and simplify it. This is where students will lose a lot of marks, is they won't write the answer in simplest form. So multiply. Look at it. I'll do example number 1 and 2, and then that's it for today, guys. I know some of you guys might have class or something. So example number 1, multiply. Well, to do this, what I would do is I would multiply the 2 tops and the 2 bottoms together. But I would make sure I factored first and canceled anything that appeared on the top and the bottom. So in this example, I can factor a 2 out from the bottom, and I can cancel the 2's. And the reason you cancel first before you multiply is just to save yourself some work. Kind of reduces the headache sometimes. You have less work to do if you simplify first. And again, like when I was a young student, this would be where I'd lose my marks because I might not always write my answers in simplest form. So number 2, for example, divide, right? Write your answer in lowest terms. Well, same as above, just one thing, we don't actually divide fractions. What you would do is you would multiply it by the reciprocal. So you would flip the second fraction and then do exactly what we just did before. Simplify this, meaning, factor it, cancel out any like terms, and then write down what's left. So in this example, oops, I didn't mean to zoom in that much. We flip the second term, we multiply it by the reciprocal, then we factored out a 2s on the top. So there's my 2s factored out. I notice that some of my terms appear on the top and the bottom, which means I can cancel them. Now, this is something I always used to mess up. Careful here. I can get rid of 2 and s. I can get rid of 2 and 1s. But remember what that leaves. It's going to leave me 1s left over. Oh yeah, this s cancels as well. So we're going to be, you can see the little tiny baby s there. We're going to be left with 1s. So just be careful when you're canceling these things. Count. If there's 2 s's on the top and there's 3 s's on the bottom, well, just make sure you leave 1 on the bottom. All right, guys, I think that's good for today. If there's any questions, let me know. Look, I have another class anyways. So a couple questions in the chat here before you guys leave me. It says, why do we not do review for a test in the afternoon? Because I have class this afternoon. Somebody, Faze, I don't know if I'm saying your name right. Everything is on the D2L. So the question in the chat is, will I give you a worksheet? The D2L has worksheets and sample tests. So everything you need for practice, worksheets, sample tests, it's all on D2L. Again, to answer Isra's question, there's no review in the afternoon because I have class. I teach like 3 other math classes. And yeah, Samira, we can do review tomorrow. I'll be around in your class time if you guys have any questions. Somebody mentions that they might need to review graphing, so we can practice that tomorrow before the test, or tonight if you have any questions. I'll be on Zoom. All right, guys, I got another class in right now, actually, in 1 minute, so I have to go. But don't forget to check out D2L for their sample tests, worksheets, everything. All right. If you guys have any questions, you can let me know in WhatsApp, or you can write me an email. I will get back to you today, but I do have another pharmacy math class that's starting in literally 1 minute. So I'll see you guys later. Again, if you have any questions, send me